This is lesson 6-7, part 1. In this lesson, we'll learn how to make an inverse function and we'll learn how to determine the domain. So if we have an XY table like this one, this is called a relation, and each of the XY pairs can be related as coordinates. So we could graph this data table and it would look like this. If we wanted to graph the inverse, then we would just switch the x and the y, and still, instead of graphing 2, -3, we would graph -3, 2, and it would go there. 5, 1 would be 1, 5, and 7, 4 would be 4, 7. So the inverse is in green. So definition for a function is for every x, there's exactly one y. One way to test to see if your relation is a function is to see if it passes the vertical line test. So as long as you're only hitting one point at a time, then it is a function. So each x has only one y. We can tell because it only hits one point at a time. And in the inverse, the same is true. We only hit one point at a time. So the inverse is also a function. So the function and its inverse are both functions. To find the inverse of an equation, we switch x and y, and then we solve for y. So to solve for y here, we would first subtract 8, and then we would divide by 2. So we get x minus 8 divided by 2. We can distribute the 2 in the denominator there, so that makes a 1/2 x minus 4. We're just dividing both parts there. And this is our inverse function, so we can notate that with a -1. That means the inverse to the y function. So if we were to graph our original function, we would use y equals mx plus b. So we start at 8, and then our slope is 2. Put a few points on here and draw the line. It's going to look something like that. Our inverse function was 1/2 x minus 4. So if we were to graph the inverse function, start at -4 and then rise over run 1/2. So our graph is going to go something like this. There's our inverse function. And notice that each of these functions pass the vertical line test. We're only touching the line one point at a time. So the original is a function and the inverse is a function because we're only touching one place at one time. Each x has only one y. So here we're finding the inverse of a quadratic. So we're going to switch x and y, and then we'll solve for y. So we'll add 1 on each side, and then we will take the square root on each side. So we get y equals plus or minus square root of x plus 1. So if we were to graph our original quadratic function, we know the vertex would be down 1, and then our a value is 1, so we go up 1 over 1, and our graph looks something like this. To graph the inverse, we can take each point and make its inverse. So our first point here was at 0, -1. So if we switch x and y, we get -1, 0. So our new point is here. If we take another point, say this one, which is at 1, 0, and we switch x with y, we have 0, 1. So that's going to be right there. And then we can take our third point here, which was at -1, 0. Switching x and y, we get 0, -1. So our graph ends up being a curve like this. Okay, doing the vertical line test, we can see that the red graph is a function because we're only touching one point at one time. But the green one, the inverse function, is not a function, so I guess I shouldn't have called it a function, because it's touching 2 points at once. So in order to make the original function and its inverse a function, we have to limit our domain. So for the original function, we would say that our domain is restricted to only all real numbers where x is greater than or equal to 0. And so on the graph, that's only positive values like this. So then when we make the inverse, the domain or the function on the inverse does not include the negative values. So it just becomes the positive square root. And in that case, then the graph is only the top half of the graph. So we would have like this. That way, both the original and the inverse are functions.